What exactly is rocket fuel anyway? First, a simple fact needs to be made clear. Try to light a match in space and it won't work. There isn't any oxygen to support the combustion. There will, however, be a spark. Why? Well, what does a match and this have in common? A match has fuel in the form of wood. A match also has an ignition system, and within this match head is the key component that we're interested in, oxidizer. Oxidizer is the bread and butter of rocket fuel. It is needed to make any combustion in a vacuum. For space shuttle boosters, the oxidizer and fuel are both poured into molds, blended and left to set. This is known as solid rocket fuel. Solid fuel has the advantage of delivering high thrust, and this thrust is necessary when it comes to escaping the Earth's pull. It also has the advantage of being cheap. No fancy storage mechanisms are needed to keep the fuel stable. There are two major drawbacks. One, you can't turn off a solid rocket, much like a match left to burn. Sure, you can wave a match around, but good luck doing that with a rocket moving at 5 times the speed of sound. The second drawback is that solid fuel has a low specific impulse. Specific impulse is, in basic terms, a measure of how efficient a fuel type is. The higher the specific impulse, the less fuel required to generate a comparable amount of thrust to another fuel. The consequence of solid fuel having a low impulse is that you're going to need a lot more solid fuel. A good combination that would do this would be liquid hydrogen combined with liquid oxygen. This combination is known as liquid fuel, unsurprisingly. Liquid fuel is the most similar to how a car runs. With a liquid fuel, it is pumped into a combustion chamber, oxidizer is added, and usually an ignition source is activated to get it going. In addition to the higher specific impulse, a consequence of this is that less mass is needed in a fuel than a comparative solid rocket to travel the same distance. This in turn means your rocket can be cheaper. The cost of making the fuel, however, sometimes negates this. Surely that's everything. Solid fuel and liquid fuel. Close, but we're not done yet. Remember how the word usually was flagged up earlier? That's because while usually an ignition source is needed, this isn't always the case. Hypergolic fuels are combinations that are similar to liquid fuels, except that they combust upon mixing. The advantage here is that no clever engineering needs to go into making a combustion chamber. Both the fuel and oxidizer are blended at the nozzle, and in turn, a simpler engine design leads to a rocket that malfunctions less. The major drawback with hypergolic fuels is that they are very toxic and corrosive. Add this to the chance of a potential leak, and you have a very dangerous rocket, particularly if it crashes and spreads fuel everywhere. Now are we done? Solid fuel and liquid fuel, which includes hypergolic fuels and non-hypergolic fuels. Well, no is the short answer. Similar to a bottle rocket, where the water is forcibly removed, generating thrust, there is yet another class of fuel that does just this: monopropellants. So far, only bipropellants have been discussed, fuels which are in 2 parts. You might be able to figure out what a monopropellant is, and yes, this does contradict what was being said earlier about the oxidizer, but monopropellant isn't being burned. Instead, a rocket using monopropellant throws overboard the propellant, and that throwing action generates the thrust necessary due to Newton's third law. Because monopropellants aren't being reacted in any way, they tend to have a very low specific impulse. They can sometimes be even more deadly than hypergolic fuels. Get a breath of hydrazine, for example, and you will have a really bad day. Monopropellants, however, are the easiest to control, and as such are employed in reaction control systems on space vehicles. To summarise, you have monopropellants and bipropellants, solid and liquid. Within bipropellant liquids, you can have hypergolic and non-hypergolic fuels. That's what rocket fuel is. Thanks for watching.